Hey, today's question is pleasantly catastrophic. What if the sun dimmed by 10% for a month? Not a cloudy week, 10% of the sunlight gone. Let's work out how fast the planet notices and which parts of life get grumpy first. Numbers first. The solar constant, the sunlight at the top of Earth's atmosphere, is about 1,361 watts per square meter. A 10% drop at top of atmosphere is therefore roughly 136 watts per square meter. Once you spread sunlight over the whole spherical Earth, divide by 4, and account for Earth's reflectivity, albedo is approximately equal to 0.30. The net absorbed energy drops by roughly 24 watts per square meter globally. That's the radiative forcing our climate system feels instantly. How big is that? For comparison, a doubling of atmospheric CO2 gives a forcing of about plus 3.7 watt per square meter. So a sudden 24 watt per square meter is huge, several times larger than the greenhouse gas step that people usually talk about. Translate that into temperature. There are two useful ways to do it. The simple no-feedback Stefan-Boltzmann estimate gives a climate sensitivity of roughly 0.27 Kelvin per W, m squared, which implies an equilibrium cooling of about 6 to 7 degrees Celsius for a 24 watt per square meter forcing. If you include typical climate feedbacks, water vapor, ice albedo, clouds, the conventional equilibrium climate sensitivity, the per watt sensitivity is larger, is approximately equal to 0.8 Kelvin per W, m squared, which would give a much bigger eventual cooling on the order of tilde, 19 degrees Celsius. Those larger numbers include feedbacks that amplify the initial cooling. Both numbers are useful, but they mean different things. One is the immediate blackbody response. The other is the full long-term equilibrium after feedbacks run their course. Crucially, the climate has thermal inertia. The oceans hold a staggering amount of heat, so in 1 month, the planet would not reach either full equilibrium number. Instead, expect a partial response, a few degrees Celsius on average globally, with larger changes at high latitudes and smaller changes in the deep tropics over that 30-day window. Models and paleoclimate analogs show the ocean slows the response, so the peak numbers are reserved for long-term change, not a single month. Regional effects matter more than the global average. The poles respond fastest and hardest. Sea ice would start growing quickly, increasing reflectivity and amplifying local cooling. Mid-latitudes would see colder air masses, more snow instead of rain in many places, and shifts in storm tracks. The tropics would lose some atmospheric moisture as evaporation slows, changing monsoon intensity and rainfall distribution. Agriculture is exquisitely timing sensitive. If a month-long dimming hits during a crop's critical window, flowering, pollination, or early growth yields could drop substantially. Hit the wrong month for staple crops in several major bread baskets, and food supply shocks appear months later. If it happens outside sensitive windows, the agricultural hit is smaller, but the risk is real and unevenly distributed. Energy and infrastructure get grumpy too. Heating demand would spike in many regions, electricity and gas networks could be strained, solar power generation would fall by roughly 10% just when people need more heat, a double whammy for grids dependent on solar. Snow and ice would slow transportation and logistics. Ecosystems would be scrambled. Cold-adapted species might expand briefly. Heat-stressed species get reprieve, but food webs are tightly coupled. And plankton, insects, and migratory cues could shift in ways that ripple unpredictably. Coral reefs could cool a bit, brief respite from heat stress, but the sudden disruptions to ocean chemistry and currents risk knock-on effects nobody ordered. And the rebound matters. When the sun brightens back up, you get rapid rewarming in places with thin ice or snowpack floods, sudden melts, and river surges. That termination shock is what geoengineering proposals warn about. If you mask warming by blocking sunlight and then stop, the catch-up is brutal. Our 1-month dimming would give the planet a nasty case of climate jet lag. Bottom line, 10% less sun for 1 month wouldn't end civilization, but it would rearrange it colder weather, stressed food and energy systems, and messy ecological knock-ons. The planet's patience is measured in oceans, and oceans are slow.